Welcome back to my channel, everybody. Hope you're having a lovely day. Today, I'm going to be completing part 3 of my SFML and C++ gravity simulation tutorial, and we're going to be creating the result that I promised you in part 1. I realize this video is very late, and probably no one even watches my channel anymore, but I wanted to complete it before I start uploading again, because I have some plans for higher quality, slightly different style, more scripted videos that I'm going to start producing soon, but I wanted to complete this series first in case anybody's still around to go ahead and watch it. So we're going to be continuing right where we left off in part 2, which is with this code right here. We have the one gravity source and the one particle, and we're going to be expanding this out to multiple particles, multiple sources, and as well different colors. So the code you can see here is the same code from part 2. We haven't changed anything. This code will be in the description in case you don't feel like watching part 2 and you are new here. But this is just the gravity simulation for the single particle and the single source point. And the code for the final thing we're going to make in this video is also going to be in the description. Without further ado, let's go ahead and get started. So we're going to be creating multiple particles, right? And so we're going to need to use the vector class in C++ to do this efficiently. So I'm going to include vector. Next, we're going to be making these particles colorful later. So let's go ahead and add a piece of code in our particle class to change the color of the particle. So we can just put it anywhere really, but we'll just call it set color. And it's going to pass in a color. And it's really simple. It's just a setting function to set the color of our circle shape here. And so we'll just go s.set fill color. Just like that. Okay, great. Now, we're going to want multiple gravity sources, right? Because we want those two that I showed you in part 1. So let's go ahead and, well, we can just remove this right here. Why not? I'm going to create a vector of gravity sources. I'll just call it sources. And I'm going to go ahead and push back, sources.pushback. I'm going to create a new gravity source. And I'm going to put it at these coordinates with this strength. I'm going to duplicate that and put it at these coordinates, the same strength. And these values here I found to be good values. You could just get these by messing around, but I'm just giving you some initial values here that are good. They are favorable. So yeah, just take Control D to duplicate that in case you want to write that line more quickly. Next, we want to pick the number of particles. So I'm going to call it num particles. And we'll go with 2,000. You might want to increase this or decrease it depending on here. Let me disable those suggestions. That's bothering me. And we're going to, set that number of particles. You might have to increase that or decrease that depending on the speed of your computer. Let's go ahead and create our vector of particles right here. Whoops. Particle like that. There we go. And now we have to actually populate this vector. So what we'll do is we'll loop over for the number of particles that we have. So num particles. Did I spell that right? I think I misspelled that. There we go. Particles. And for each one, we're going to do a few things. We're going to be setting different colors for each particle, but we're not going to do that quite yet. We're going to start with particles.pushback. We're going to just create the actual particle itself first. So we're going to create a new particle using the constructor. I'm going to put it again at these coordinates. This is sort of a pre-found coordinate. I've found that this is good. And for the velocity now, what we're going to go ahead and do is for the x velocity, we're going to set it to 4. And for the y velocity, we're going to do a couple things. We are going to start at a y velocity of 0.2, and then we're going to add something to each one of these, which is going to be 0.1 divided by the number of particles. This is to make sure that it stays the same. No matter how many particles we have, it'll just be increasing the detail. It won't be like getting different velocities. The velocities will still fall in the same sort of range, if you know what I mean. Let's see here. And then times I. So what this essentially is going to accomplish is we are starting all the particles at the same x and y position with the same x velocity, but we are going to start them with slightly different y velocities. So at the base of 0.2, we're going to basically distribute them evenly over a range, a very small range of from 0.2 up to 0.2 plus 0.1. So 0.2 up to 0.3 essentially. Okay, so we've created these particles, and right down here, let me put a semicolon there, we would change colors, but we're not going to do that quite yet. Let's go ahead and make sure we can actually render all these particles and gravity sources as well, and all that stuff. So first here, this code is obsolete, so we'll remove that. The first thing we need to do is update the physics for each one of our particles. So what we'll do is we'll go for int I equals 0. I'm writing code like Python, which is not correct. Okay. I is less than gravity, sources dot size. I++, we're basically going to loop over for each gravity source. And for each gravity source, we have to apply that gravity source's influence on the particle. So what we'll go ahead and do is we'll again loop over all the particles now. If j equals 0, as long as j is less than particles dot size, we'll increment j. There we go. And now what we can go ahead and do is go particles at j dot update physics, and we will pass in sources at I. That's great there. I think I forgot a semicolon right in there. There we are. Go ahead and zoom in. So we have that. Fantastic. This should update all the physics now for all the particles. Now we need to go ahead and render all the sources and all the particles. So we'll go we'll go ahead and copy this code right here. I'm just going to copy this line because we're really just looping over the sources again, right? And so we'll just go ahead and go sources dot sources at I dot render. We'll go ahead and pass in the window, which I think is called window. There we go. And we'll have to do the same thing now for the particles. So again, I'll copy my looping code for the particles. There we go. And we'll go particles at j dot render window. All right, let's go ahead and run this code and see where we're at. So now you can see it's sort of like a blob, and it looks kind of like a little worm. And it'll just go ahead and loop around there, and it starts splitting up because the different initial velocities result in different paths. Even if it's a very small difference, they will do drastically different things as time evolves because it is a chaotic simulation. So this looks very cool, but I think it would be cooler if we added some colors. But before we add colors, I'm going to actually go ahead and just reduce the size a little bit. For the particle, 8 is a little big. They look kind of chunky, so I'd rather go with 5, and we can see how this looks later. Maybe 6 because it's a YouTube video, so YouTube will probably compress it a lot. So at this point, what we need to do is we need some way to color the particles based on their initial velocity. So the initial velocity is based on the index, so we'll basically just color based on the index. So how are we going to do that? Well, we're basically going to create a function that's going to linearly interpolate or smoothly sort of transition. As the input goes from 0 to 1, we're going to smoothly transition between 3 different colors. So let's go ahead and do that. SF color is what's going to return. And we're just going to map value to color, float value, and value is 0 to 1. So we'll go ahead and create that. So first what we want to do is we want to actually clip this value. Just in case the value is for some reason less than 0 or greater than 1, we want to make sure that it is clipped to those values so it doesn't do anything bad. So first, if it's less than 0, we're going to go ahead and just set it to 0. And Control D to duplicate that. If value is greater than 1, then we'll go ahead and set the value equal to 1. Okay, great. So the clipping is done there. Next, what we're going to do is we're going to initialize the red, green, and blue components to be 0. R equals 0, G equals 0, B equals 0. There you are. And we're going to basically interpolate. So we're going to go between blue, green, and red in that order. So first, between 1, here, let me make a comment here. Between 0 to 0.5, we're going to interpolate blue to green. And then between 0.5 and 1, we'll be interpolating between green into red, which will create this nice gradient that I'm looking for. So we'll start with the first part. So if value is less than 0.5, then we're going to go ahead and set the blue value to 255 times, and we'll do 1 minus 2 times value. Minus 2 times value. And these constants, these like numbers here, are just coming from the math of interpolating between 0.5 and 0. I'm not going to explain how I got them. For the green, it's going to be 255 times 2 times value. There you are. All right, done there. And we can go else quite safely because we know the value is now definitely greater than or equal to 0.5. What we'll go ahead and do is just set the green in this case equal to 255 times 2.f minus 2 times value. So slightly different math here, but that's this is a 2 because we're on the second chunk now. We're 0.5 to 1, not 0.5, if that makes sense. And for the red now, because we're going to be interpolating to red, so that equals 255 times 2 times value minus 1. There we go. And then we're going to return a color, which we're going to build using the values we have added here. So return SF color RGB. There we go. Okay, so we have this function now, and we're going to go ahead and actually apply it. So how are we going to do that? Well, we need to first convert our index to a value between 0 and 1. So what we'll go is float val, and we'll set this equal to, we need to first cast I to a float, and then we can divide it by casting, casting the number of particles to a float. And then, yeah, that's done there. So now this will basically, as I increments from 0 up to the number of particles, it will be scaled from 0 to 1. We can then go SF color col equals map value to color value, just like that. And then we can go ahead and go particles at I equals, dot set color equal to this color we have now found. Let's go ahead and run this. See what that looks like. And you can see now it looks kind of like a snail here. I can full screen that. It might scale a little weirdly for the video, but it looks kind of like a multicolored snail now. But really it is just different particles. And you can see there as it starts splitting off, you get this nice effect. And that's pretty much it. There's nothing more to it. Now let me go ahead and increase or set the camera here. Yeah, that's reasonable. So yeah, you can basically change yourself if you want what colors it's linearly interpolating between. You can add multiple or just make it 2 or something like that. Tweak the initial velocity. You can change the range or the initial positions of everything and stuff like that. But yeah, that's pretty much it. So not a whole lot to do really. Quite simple. The code will be in the description. The final code that is. You can go ahead and hit me up on Instagram or Discord if you have any questions. Those will be in the description as well. And yeah, stay tuned. I'm going to be posting some more videos soon. I'm working on one script right now, and I have about 3 or 4 other ones planned. So yeah, stay tuned for those, and hope you guys have a great rest of your day. Later.